Right before the Ethereum merge, a few heavily discussed terms on client devs calls are censorship resistance, PBS, and mev-boost. If you want to learn what this means to miners, stakers, and developers, stay with us. Welcome to PEEPanEIP episode 93, a series dedicated to sharing information on upcoming proposals and protocols for Ethereum blockchain. I'm Pooja Ranjan, and to provide an overview on Proposal Builder Separation or PBS, we are joined by Barnabé Monnot. Barnabé is a researcher and a member of Robust Incentive Group at Ethereum Foundation. We have him on the show earlier to talk about his analysis to support EIP 1559. Check out episode 37 on PEEPanEIP playlist at Ethereum Catalyst YouTube. Coming back to the post-merge world, let me welcome Barnabé Monnot. Thanks for joining us, Barnabé.
Hi, thank you for having me again on a different topic.
Right. Like many others, I'm very thankful to your research work done for the Ethereum protocol. So before diving into today's presentation, will you maybe share a little bit about your background, yourself, to let our community know more about your journey with Ethereum blockchain?
Sure. So I started getting into Ethereum while I was doing my PhD thesis. My thesis was on game theory, but not applied to blockchain, applied to something else. And I started getting into Ethereum, realizing, oh, there's a lot of like these nice game theory type problems of mechanism design in Ethereum, and the community is like really awesome, and the project was so interesting. So after my PhD thesis, I joined the Ethereum Foundation, and we started this robust incentive group. That was in January 2020. So it's been almost 3 years that we are doing research, and yeah, we've been working on, I would say, most of the big upgrades, proof of stake, EIP 1559, now proposal builder separation. Some of us are also working on rollups or different topics. So I would say we've really expanded our range, and we're trying to still deliver high quality research for the community.
That is awesome. It's really interesting to learn about what's going on in the Ethereum community and how people join the community. I believe it inspires people to join without any hesitation. So yeah, thanks for sharing all these. And without further ado, let's peep in.
So right, hi everyone. So this is hopefully short and interesting presentation on proposal builder separation. I think it's one of the most important changes that is currently considered for the protocol. So today my aim is to try and widen the frame a bit, to give a sense of why it's happening and why it's kind of already happening today, and then talk a bit about the outstanding research questions and give you like more background on what we're currently thinking about relative to proposal builder separation. So yeah, I've been talking about this concept relatively recently, the idea of protocol agent problem. So in economics, you have this idea of principal agent problem. You have a principal like an employer, and you have an agent that you delegate some function to, like running your shop or something. And you're trying to ensure that the person you're delegating to is doing as good a job as you would do yourself. And so the first thing that we see, like the first kind of instance of this principal agent problem that we see, and it pops up everywhere in the centralized system because we're constantly like dealing with other parties, is really that you have this Ethereum protocol. Like you can think of it as a fuzzy set of rules and specifications, like how do you run the Ethereum blockchain? And that fuzzy set of rules and specification is somewhat delegated to an actual set of physical full nodes that are running that protocol. And this is the network of validators, so the ones that are bonded, staked in the system and produce the blocks, make the votes and everything. And so for these validators, to align their incentives with the incentives of the Ethereum protocol, you have rewards, penalties that try to say, okay, if you do a good job, you're rewarded. If you do a bad job, you're penalized. And so, yeah, so you really have this first, let's say, original delegation, like to run your network. I'm picturing it like this, and I'll come back on this graph throughout the talk, and I'll add like more things. And so, yeah, so you have like this boundary of a protocol, like what the Ethereum protocol sees and what it tries to have control over. It tries to have control over this network of validators. It doesn't have full control. Validators maybe have a bit of space to make their own decisions, but the protocol exerts some amount of control via the rewards and the penalties. Rapidly, like, let's talk a bit about how you become a validator. So this is the equivalent of being a miner in proof of work, but now in proof of stake, you have to stake, so you lock up 32 ETH. After some time, you get activated, and then as a validator, you're called upon to perform some consensus duties. So once in a while, you're sampled from that very large set of validators. And when you are sampled, you have to make a block that contains both consensus data, which is the votes, and execution data, which is the transactions. And then relatively frequently, every 6 minutes or so, you are called upon to produce what we call an attestation, which is your view of the consensus and which the protocol uses as a way to finalize blocks and coordinate everyone over a single ledger view. And so, okay, so I said earlier that, the protocol sort of delegates its execution to this network of validators. But now what's surprising today and what we are talking about in this talk is that we observe that validators start delegating their core functions, which is the core function of making a block, and more specifically, the core function of packing these execution payloads with transactions. The validators are delegating that to another set of parties that we now know as the builders. And the object of PBS is to understand that relationship that creates between the validators and the builders, and understand like why it came about and what is the best way to organize it. So that's really what I'm planning to dig into here. So yeah, to understand like why this delegation happened in the first place, I think it's really nice to take a step back, or rather like get into the nitty-gritty of how do you make actually a good block. If it was so easy to make a block, like there would be no need to delegate your functions as a validator. You would just make it yourself. So what makes it so difficult to make a good block, and why do we see the emergence of this network of builders? So I said earlier that the protocol boundary doesn't extend all the way to cover like everything that the validator does. And so one thing that the protocol doesn't cover is exactly how the validator is expected to make the block. There are not really inclusion or ordering constraints. There's really one or two constraints. So the first constraint that validators have to abide to is they can't put transactions in their block that don't pay the EIP 1559 base fee. So you have this fee market, the protocol requires at least a reserve price for the transaction. If the transaction doesn't pay that, you can't put it in your block. That's one constraint. Another constraint is you can't go above the gas limit of your block. So you can't pack the block with more than 30 million worth of gas. So these are two constraints, but they're fairly weak, right? So when you're a block proposer, you have your mempool. You can decide to insert all the transactions that pay the fee as long as there's enough space. You can decide which way to order them. You can decide to leave some out if you, for some reason, don't want them to be included in your block. You can insert your own transaction. This is an important thing that we'll come back to. And so, yeah, so you really have like a very large space of how you make your block. And so what we observed early into Ethereum and maybe until 2018, 2019 is it's somewhat incentive compatible for the block proposer to order transactions in decreasing order of gas price. So packing the most fee-paying transaction at the top of the block and then going down from there. And the reason is the first spot in a block, it actually has a lot of value, because when you are the first transaction to be executed in a block, you can do a lot of arbitrage. So you're acting upon the state left to you by the previous block, but now the markets have changed, prices have been updated, and you really want to be like have that first slot, be the first one in the block. And because this has a lot of value, if the block proposer says, I'm just going to order transactions in decreasing order of gas price, it leads to this incentive to try to bid as much value as possible to the block proposer so that you get as high as possible in the block. And what we're picturing here is a very famous plot from Phil Diane's paper and his co-authors, Flash Boys 2.0, where you see two bots that are trying to one-up each other by making bids and replacing their bids over time so that they get that first spot in the block. And we know this has priority gas auctions. And so what this tells you is really that the ordering matters in the block. And the ordering is another way to say it is you want to act upon some kind of state of the blockchain. And the value of your transaction really depends on if the state you're executing it on is valuable or not. So for instance, if the arbitrage still exists at the moment you're sending a transaction, you may stand to make $1 million. But if the arbitrage is gone, if that state is, okay, the arbitrage has already been wiped out, you don't make anything from your transaction. And so whoever is trying to capture the arbitrage is willing to spend up to $1 million to get the right to act upon that specific state of the chain. And so if you think about it, who is the best placed to capture this arbitrage? Like who has the ultimate power to act upon any state of the chain? And that's the block proposer. So the block proposer is really the person who has the final word on what goes into their block, in what order, and they can even insert their own transactions. So if nobody is picking up that arbitrage, they can be the ones doing it by just inserting their transaction in the block. And so if we think in terms of mechanism design, like if we say, okay, this first slot is very valuable, what is like a good mechanism to allocate it to the person who cares about it the most? And we can go through alternatives. I think it's kind of helpful because at the end of the day, we see sort of the seeds of how this proposer builder separation has been operationalized from the start. And so let's think of a very simple allocation is you don't have any rule for allocating this first slot. What you see then is what we just described. You have priority gas auctions, which is an ascending price auction, but it's very wasteful. You have bots competing in the mempool. It creates a lot of congestion. You have many trades in the block that are failed because they're all trying to get that first slot, but when they don't, they use a bit of space with regard to transaction. So that's not so great. Another idea, how would you allocate this first slot is you, let's say as a proposer, I could say, whatever I see in the mempool, I'll just pick one at random and I will put that as my first transaction in the block. It's not incentive compatible. As a proposer, I would want to use the decreasing gas price order because that leads to these priority gas auctions that pay me more fees. But let's assume that for some reason I commit to that rule. It's very wasteful. If I'm trying to get the arbitrage as a user, what I will do is this spray and pray, where I just like send millions of transactions in the hope that one of them makes it to the top of the block, like it's chosen by the block proposer. And so you have a lot of spam, and it's not really a nice way to deal with that. Another one that people are discussing quite often is the idea of first come, first serve. So you say, well, it's fair if the first person who realizes that this arbitrage is there gets the right to extract that arbitrage. But operationalizing this rule in decentralized system is very difficult because you have many block proposers, you have many people who are trying to come to consensus over, well, actually, who was first? Like you have to come to consensus over it because the block proposer, they can cheat. They can say, oh, my transaction came first. And so if you have to come to consensus, it induces what we call latency games, where people are just trying to rush so that they are very fast to get their transactions into the first come, first served queue. And it wastes a lot of value. So if you have $1 million on the table, but on the, let's say on chain, these people are going to try and spend $1 million to improve their network infrastructure, like build very fast fiber optic connections, like high frequency trading, and get that arbitrage. And so, yeah, it's a bit of a waste because then that value just flows out of your system. Another thing that we started seeing appearing, I would say 2018 and 2019 is private channels. So you would just have mining pools saying, if you care so much about this first slot, just send us like under the table an offer for how much you care about it. and we'll put whoever is giving us the best offer at the top of the block. That type of thing, it tends to favor, I would say, dark pools. So the idea that now you have exclusive order flow, you have very close integration between the block proposers and the people who are making this arbitrage. So it can lead to centralization vectors that are not super desirable. And then another way is auction. So you try to have some kind of open auction where you say, well, this first lot is valuable to most people. Let's just auction it off and try to see who can give the most value to capture that thing. And so now you move to the system where you're thinking of bundles, and bundles are just packages of transactions. You can think of them as arbitrage that are trying to bid for the right to have this top of block inclusion, right? And so, as I was saying earlier, the block ordering is not at all in the control of the Ethereum protocol, and it's something that the validators can decide by themselves. So, okay, and so now we have these options. So we have this system where you have entities that we call searchers that are trying to bid to the block proposers for the right to get their bundles into the block. So if I'm a searcher, I'm trying to capture that $1 million arbitrage. I'm going to try and say to the block proposer, okay, this is worth $1 million. We'll do 50-50. I give you 500,000. I keep 500,000, and you put me at the top of the block, and I extract the arbitrage. That's fine. But if the searcher market is competitive, you expect that another searcher will say, oh, you know, this guy is giving you 500,000. I'll give you 600,000. And the more searchers you have and the more competition in that market, like most of the value of the bundle, most of the value of the arbitrage is kind of given back to the block proposer instead. So the auction reveals that this bundle has a certain value and searchers compete. And so that value is coming back to the block proposer. And that auction was known as the Flashbots auction. There's been others that were deployed in proof of work, and they relied on a somewhat permissioned, let's say, marketplace between the block proposers and the searchers who were contributing these bundles. That worked because you had mining pools which were reputable. You had searchers that were comfortable sharing their bundles. The bundles contain a lot of very valuable information. It's basically how to extract that value from the bundle. And so, yeah, so it relied on some trust between the mining pools and the searchers who were publishing these bundles. And now we move to proof of stake. So September 15, 2022, we don't have mining pools anymore. We have some staking pools, but what we do have also is a lot of solo validators. So people who are just staking from home, who are not reputable entities, who are not appearing very often, not making a lot of blocks. And then searchers say, well, I don't know that I can trust these people who I don't have reputation on or visibility on with sharing like my whole bundle flow with them. And so the system that was devised is, instead of having searchers share the bundles and the proposers making kind of the rest of the block after the bundles are shared, is having instead an auction where builders are submitting full blocks to the validators. So the validator basically completely delegates the possibility to make the block to these builder entities. And same as before, these builders are basically selling away their blocks via an auction. So they're saying that block is worth this much to me, and so I am willing to give it to you, the proposer. And so now we move to this system where, yeah, it's no longer bundles given to the proposer, but it's the whole block itself made on behalf of the proposer. I like this picture a lot. I think it gives you like a lot of insight in a very concise way. And it's the idea that, yeah, most of the value, if the market is competitive enough, like if the searcher market is competitive, if the builder market is competitive, like they're going to try and outbid one another until all the value somehow trickles down to the proposer, who's again the ultimate arbiter of what gets into the block. Yeah, and so this value, really what it is is MEV, like what the value that can be extracted from the proposer being this all-powerful entity at the time of making the block. Okay, and so really that's the presence of PBS. So the system that I just described with the builders and the proposers, you can really think of it as PBS today, live on the Ethereum protocol. It's known as mev-boost. It was deployed by Flashbots, but it's a neutral marketplace in which Flashbots does interact as a relay and as a builder, but it's open to much more builders and relays than just Flashbots. And so very briefly, like how it works to give a sense of the mechanics, is you have 3 phases. In the first phase, the builders send their full block and their bid to what we call the relay. So the relay, it sits between the proposer and the builder. So the builder is not going to send the full block directly to the proposer because they still want to make sure that the proposer makes a strong commitment for it before they release the data that the block contains. That data, again, is very valuable. And so the relay acts as this kind of middleman or broker that is making these deals between the proposers and the builders. So the relay takes the full block and the bid of the builder. It validates that the block is valid, let's say from an EVM perspective. It validates that the builder is indeed paying the bid that they announced. That's the first phase. In the second phase of the bid selection, the proposer gets all of his bids without the blocks, just the bids from the relays. And by default, mev-boost today selects the highest bid. So you have some options now where you can modulate the behavior of mev-boost. You can think of it as taking in a stream of bids and just saying, okay, I like that one, which is the highest, and I'll commit to it. So proposer says, okay, I'll sign that bid. That bid is actually a block header. So once the proposer signs it, they can't sign something else. Like they can't see the contents of the block once it's released and try to double spend or to steal the contents of the block. When they sign the bid, if they make any other block than the builder's block, they can get slashed. So it relies on this economic incentive that the proposer can't cheat the builder. And so when the bid is signed, the relay receives the signed bid, and then it releases the full block to the network. So you have this game where the builder is trying to get a commitment from the proposer, and then the proposer is able to say, okay, I committed to it, now release the block, and let's share in that value. So just to recap with, I think a plot that's helpful to have in mind is the different ways that you can build a block today in proof of stake. So you have always the option to use your local block building. So your execution client is going to look at the mempool, pack a block itself, propose that to the consensus client, and propose it to the network. But if you want to, you can also connect to that mev-boost software, so mev-boost marketplace via the builder API, and receive these blocks from this external block building network. So yeah, it's very much like more complex. It has a lot more moving parts than the local block building, but it does allow you to access this wider network of people who are very good at packing the blocks and giving you most of the value that you could extract as a proposer, which is why it's so attractive to proposers today. And I think the latest number was around 90% of validators have activated mev-boost. There's some degree of agency for the proposer when they use mev-boost. They can select which relays to connect to. So today relays have some kind of market differentiation in terms of the kind of content they put in their blocks. So if they put good MEV or bad MEV, if they leave out certain transactions, like if they censor or not. So the proposer is able to choose which relays to connect to based on their own preferences. Okay, so that was kind of like how PBS arrived on the scene and the economic reasons why you see this separation. Now I want to get like into maybe a bit more theory and address like some of the questions that I often see people asking when they think about PBS. So first thing to notice is we actually do have PBS today. So many people say, oh, when is PBS hitting mainnet? In a sense, it already is, because PBS is not a specific in-protocol mechanism, but it's really this idea or this architecture that tells you, okay, proposers are outsourcing part of their block construction to someone else. And so that is expressed today, but it's out of protocol via this mev-boost software. To guarantee that out of protocol market, you have the relays, which are the trusted parties. They validate the good that's being sold. They guarantee the payment. So you have a system that works. And the evidence that it works is many proposals have opted into it. So what you can ask as a protocol designer is this enough? In a sense, should the protocol recognize that, okay, most of my network is delegating the block construction to builders? Like, should I be doing something about it and start concerning myself with that separation? That could be block building tomorrow. So what I think most people refer to when they talk about PBS is the idea of in-protocol PBS. So removing the relays and having the protocol itself become the broker or the middleman between the proposers and the builders. And so we remove that relay row that was in the middle here. Again, picturally. So let's say that's the situation today. We have the Ethereum protocol that has currently like no idea that proposers are using builders. It sees that blocks are being made. At the client level, you have this builder API, but that's not, let's say, a protocol rule. It's more a facility that the clients have built into their software. And so the Ethereum protocol itself is still in this paradigm where, okay, validators are making block, I reward them, I penalize them, they get fees, they get stuff. But it just has no idea that validators have been delegating this block construction to the builder. And so the question is, do we make the protocol have such an idea? So do we move forward the boundary of the protocol so that we recognize that, okay, builders exist in our network, and we entrench them as protocol actors? I think it's a very important question, and it's not something that should be done without like careful thought, because whenever you try to move the boundaries of the protocol, like you say, well, am I doing it right? It's costly to move that boundary. It's costly to do anything at the protocol level. So you really want to make sure that it's worth it. And so some elements of response here. And again, I don't claim like to have a full picture. It's something that there's a lot of open research on, but I just try like to give some ways to think about it. And the first thing is, why delegate in the first place? So when mev-boost started and when there was these concerns around censorship, I think a lot of people were naturally and almost positively careful to say, well, okay, we might not want that at all. Like, we might want proposers to make the block themselves so that we keep like this protocol running. But the fact is, there might be like opportunity in having this builder separation. And this opportunity comes from the fact that there's a bit of a natural asymmetry between making a block and verifying a block. So the role of a network as a whole is to check that the protocol is executed correctly. But at the time of making a block, at the time of appending something to the blockchain, this might require a lot of resources or a lot of knowledge, and then the builder role might be very helpful. So for instance, the block construction, so packing the transaction in the block, it's a one-shot exercise. Like, it might require a very sophisticated algorithm to pack, to do arbitrages, everything. But once that's done, the work to verify that the block is correct, that the block is valid from an EVM perspective, this is fairly cheap. You just have to execute the transactions. And so what you want, since making a good block is hard, or making, let's say, the optimal block is hard, is you don't want to shut out proposers who are untrusted or unsophisticated from accessing these very good blocks. Because if that's the case, if you say, well, there's no mechanism for you as an untrusted proposer to access that network that can make very good blocks, you start having an economic centralization effect where the rewards that these solo validators are getting, they're just not as much as the rewards that very sophisticated pools or very reputable pools can get by having access to this builder network. And so really the idea of proposer builder separation is making sure that these superpowers that the builders have are somewhat fairly distributed over the whole network, and that the network stays decentralized by this effect. Some opportunities of outsourcing, for instance, something that we can't really do without a builder role is Danksharding. So Danksharding is this proposal to greatly expand the data availability that the Ethereum protocol can provide, and to get that huge increase in bandwidth of data, you really need to have very powerful entities in the network. So these builder roles. So the builder in Danksharding is responsible for making let's say a mega block. So something that is 16 megabytes per block. It doesn't sound that big, but if you are the person who's making the block, at the time you're making it, you have to send it to gossip it over many of your peers. So the bandwidth requirements are very high for you. But once you make that mega block and once you disseminate parts of it on the network, you can basically shard the contents of that block. And then for the rest of the network, let's say solo validators with just regular consumer internet connections, they don't need to see the mega block. They can just play these games of data availability sampling and verify for themselves and for the rest of the network that the data is indeed available. And so you have, again, this asymmetry that a very good builder that can summon very high resources can do something very nice, like just improve the capacity of the network without imposing that cost to the network as a whole. So yeah, you can have big blocks, and also you can make sure that the big blocks are still verifiable by your network as a whole. And the max capacity just can't be provided without this builder role. And so that's really an opportunity of PBS. But there are risks also. Every time you delegate something to someone else, there's always the risk that that person doesn't really do what you want them to do. So this principal agent problem. And one of them is very clear today, is censorship resistance. So if we go back to these interlocked sets of delegations, the first thing was, okay, the Ethereum protocol kind of tells you should be neutral and you should include any and all transactions which pay the fee, right? Like if you're a block proposer, you see a transaction that pays base fee and maybe pays you a little tip, it's rational for you to include it. That's the protocol. Now, do proposers always include every transaction they see? Some proposer might decide that they want to censor transaction, but then you really rely on the fact that your proposer set or your validator set is very decentralized. And in that case, if someone doesn't include the transaction, you know that fairly soon another person is going to include it. But now you have this phenomenon where proposers are outsourcing block production to agents that by design are much less decentralized. So if we say, okay, builders have to be sophisticated, they have to have all this knowledge to make very good blocks or very high resource requirements, like you should expect that the set of builders in your network is going to be much smaller than the set of validators that are bonded in proof of stake. And so the builders, they might have their own preferences. Like if they are legal entities in some jurisdiction, they might say, you know, there are some transactions I don't want to put them in my block, despite the proposer's preference. So the proposer might have no problem with a transaction being included, but the builder may say, you know, not in my block, and then the proposer can't really do anything about it. Or can they? A solution that came up a year ago is the idea of getting the proposers to require the inclusion of some transaction list by the builder. So when they tell the builder, you know, make a block for me, they require the builder to include some transactions, and we call that inclusion list. It's a proposal by Francesco. You can do inclusion lists out of protocol. Like you could build some kind of inclusion list in mev-boost, for instance. But the fact is that it works better if a protocol is involved, and if you can build these inclusion lists in a way that one proposer builds it for another proposer. I won't get into the details here, but I'll give a link at the end where you can read more on this discussion. And just very briefly, last couple of slides. Okay, we've seen like why people delegate. We've said, okay, there are opportunities, there are risks. Now the question is, why should we move that in protocol? So we know that delegation happens and we have ways of organizing this out of protocol markets. Why do we as protocol designer maybe care that we need to move PBS in the protocol? So the first thing that I was pointing out earlier is you can remove the relays. They're kind of extra points of failures or vectors of centralization risk. Another thing is you can guarantee payment. So now that the protocol sees the builder as protocol agents, the bids are also binding with respect to the protocol. In mev-boost, you have some failure cases, which are now fairly rare, which were maybe more problematic at the beginning, but as the market matured, it seems like it's fairly stable. But we could have cases where the relays failed to validate the bids, and the proposer thought they were getting $1 million, and then they just end up getting $10. So if you have in protocol PBS, you have ways to make any bid that is made by the builder as fully binding. And if the builder says, I'll pay you 1,000 ETH, they have to pay 1,000 ETH. Another thing that might be nice is, and maybe I won't talk about this too much, but the idea of consensus bids. So the protocol now can see the auction happen, and it can get a sense of what's the actual correct value of the block. In a sense, it elicits the true value of the block via the auction, and it's able to detect that and to action upon this knowledge. And this can be used, for instance, for MEV smoothing or MEV burning proposals. There are some reasons to do in protocol PBS, some reasons why we might not want to do in protocol PBS. The first one is always, it's just more protocol complexity. So you add overhead to the consensus. Now there are designs that exist for in protocol PBS, but most of them require extra steps or extra feature that you add to the consensus. This is always ripe for failure cases. Usually things are, we get it right, like it's tested a lot, but it still means that you just have like more complexity and more overhead. Another question that I think is maybe more important is, if we do in protocol PBS, in a sense, we are enshrining a very specific market structure. And the market structure is proposers are delegating to builders to make their blocks. Now, the question is, do we still have builders in 10 or 50 years? So sometimes we think like you want to build a protocol so that you don't have like to tweak it every 5 years or so. It has to ossify. And if you build in the protocol this idea that there's a separation between proposers and between builders, maybe we can't get rid of it. And maybe it's irrelevant in 10 or 50 years where we have super amazing cryptography or proposers with like really high bandwidth. Then we're just like stuck with that mechanism. And another thing is, we also need to make sure that whatever we enshrine, we get like the exact shape of the mechanism right. And here you really have like a very large design space to do PBS in protocol. And the design space really has to do with the way you're doing the auctions. For instance, you could decide to do a partial block auction where the proposer makes one part and the builder makes another part versus a whole block auction. You also have like some design space around when the builder needs to commit to the block contents. So there's this idea of block auction and slot auction. In the block auction, the builder commits to block content before the bid. In the slot auction, they commit after the bid. So it's a bit more flexible. There's a post by Julian, who's a researcher at the RIG, that will come out very soon on this. And then you also have this idea of timing games, which is this incentive for people to be as late as possible to do their duties. So you want to be the last one to place your bid because you have the most information, the most MEV. If you're a proposer, you want to be as late as possible to propose your block so that you capture like the most MEV possible. And these timing games, like they tend to appear in very nasty ways in these scenarios. As a note, if we feel, okay, maybe we are not compatible with in-protocol PBS, we can still do these inclusion lists in protocol without having in-protocol PBS. We still have ways to deal with censorship if it's really a problem at the protocol level without going through like the whole trouble of enshrining PBS in the protocol. So I think this is something that maybe is overlooked in the public discussion around PBS. Okay, almost there. When mainnet. So I think that was, the idea of this PEEPanEIP is that you talk about EIPs, you talk about things that are fairly close to being deployed. The fact is there's no EIP today for PBS, but in a sense, PBS is already on mainnet. It's just not in protocol mainnet, but mev-boost is part of the Ethereum network, not part of the protocol, but part of what network agents are doing. And so, yeah, so then the question is the value of PBS in protocol like stronger than the cost of doing it? Or do we feel confident that it's like a good way forward to enshrine PBS in the protocol? And in my opinion, there's more research that is needed to evaluate both options. But it's very interesting. Like even if we decide not to go with it, or if we decide to go with it, I feel like the research questions that this has prompted, they've been very productive on many other fronts, such as understanding MEV, understanding the space of mechanisms that the protocol can do. So it's been like a really productive research trend. And I'm mentioning here that I released a post a month ago that tries to tie up like all these different questions and to give like this more clearer picture. A brief recap, because it was maybe a long talk. So what is PBS? The idea of PBS is really like a design pattern or an architecture. It's having part of a block construction done by someone else than the validator. Is PBS an EIP? No, but it's an architecture that can be instantiated in many ways. And when we do, if we do PBS in protocol, there will definitely be an EIP that will explain how to do that. Is it currently in protocol? It's not, but it does exist today in the form of mev-boost. Does it solve censorship? No, and to some extent, maybe it makes it worse because you have these builders in the network that are more centralized and maybe are more likely to censor builders or relays in mev-boost. But really what it tells us is it's kind of revealed that maybe the person who's the best able to make the block is also the person who wants to censor it. And it's a bit of a unfortunate outcome, but it's one that seemingly is not unresolvable and seems to improve over time. And especially we've seen like more and more blocks that are built by builders and relays that declare themselves as non-censoring. And so it does feel like the market is trending in the right direction for this. If we move PBS to the protocol, would we immediately solve censorship? In a sense, not really. Like we would remove the relays, so maybe we remove that choke point, but it does leave the market structure somewhat the same with proposers and builders. So PBS maybe doesn't help, but having inclusion lists in protocol, that can be helpful to mitigate the censorship if it does get too bad. And then is PBS only for the execution payload, so the one of the transactions? No, actually PBS is much more general. It can be used for Danksharding. So it's not the execution payload, it's what we call the data blobs. And maybe in the future, like as we add more features to the protocol, such as statelessness, or even maybe we have zk-EVM enshrined in the protocol, then we might have some use for these builders to provide state witnesses, provision the state to stateless validators, or make these validity proofs based on the enshrined zk-EVM. So yeah, there's plenty of ways that PBS can be helpful in the future. And yeah, that was it. Thank you for listening. I hope this was interesting and that it gave like a bit more insight into PBS. And now I think I will take questions from Pooja.
Awesome presentation. I think it explained difficult terms in a simple way. Slashing conditions will keep validators in check, which is helpful for the security of the network. Last slide, I think, was the best. The recap was great. Well, obviously, this has helped get answers to many questions that our listeners and viewers may have in mind. We, however, will take a few more questions to maybe get more clarification for people trying to get involved.
I see a question on the chat. Should I answer it now? The proposer has chosen the highest bid. Why would they want to change that bid in post-sign? Yeah, that's a good question. So they wouldn't want to change the bid, but they might want to try to get the builder to reveal their block, copy-paste that block, but replace everywhere that the builder is making money with their own address. So they might try to steal the alpha that the builder block contains to to get the whole value for themselves, like not sharing anything with the builder. And so that commitment is helpful to ensure that the builder doesn't release the block before the proposer commits to proposing that one. Yeah, that's a little detail in that mechanism, but actually it's very important, and it really drove most of the mechanism design for this architecture. Is this enforced at protocol layer or just in mev-boost? So the mev-boost won't allow you to double sign a block. So you could like hack your client so that when you get a mev-boost block, like you try to make another block once you see the builder block being released. But what is enforced at protocol layer is if you do make two blocks, one that you got from a builder and one that you made yourself, and you sign both of them, someone is going to slash you, and that's going to be enforced at protocol level. So it's always in your power to make two blocks in the same slot, but you're going to be slashed for it. So you probably shouldn't.
So my first question is related to the PBS design. In your slides, you talked about what are the proposed design solution to allocate the first slot to maybe overcome the censorship. If I missed, can you maybe specify why the first slot is so important for many people?
Yeah, I would say maybe you can generalize the first slot to acting upon the PoS state that the previous block has left you with. It just happens to be that, if you're trying to arbitrage, let's say like a Uniswap pool, like you want to be the first one in the block who touches that pool. So maybe what you care about is not the first slot exactly, but it's to be first in relation to everyone else who is trying to access the same, let's say, pool or address in the state. And so, what it looks like is just that people are trying to outbid one another so that they land above their competition. So I call it first slot, I think, more as a mental model, but you can really think of it as, you're just trying to race ahead to be the first. And the race is not based on time, it's based on how much the bid you're making like puts you ahead of your competition.
That makes a lot of sense. Another question, maybe slightly on a related note on design. So in the first post that was shared by Vitalik Buterin, there were mention of a lot of designs. There was something called like friendly fee market design. So could you maybe talk a bit more about that?
Yes. So there's been like a few ways to do like in protocol PBS. Most of them have been designed by Vitalik, and he's the one who has posted on this topic quite a lot on ETH Research. So the first one was this idea of proposer builder friendly fee market. It was a design that relied on, the builder would send something to the proposer would commit, and then you have to have some kind of trust that the builder does their job or the proposer does their job. So that first post, let's say, had some issues with the mechanism, but what it was trying to get at is, okay, how do you make this fair exchange between the proposer and the builder, such that neither the proposer nor the builder can sort of grief one another. That's the first post that was there. The second post, I think, is probably what I would say the most credible option for protocol PBS. It's called the two-slot design. So in that one, you think of like the slots that we have today in the proof of stake consensus as you divide them in two. First, the proposer listens to all the bids from the builders, and then we make like a consensus block that says, okay, this is the bid that I'm picking. And you have attesters that are voting on that block. So the attesters, they make safe the fact that the proposer has committed. And then the builder sees, okay, the proposer has made the block. The bid is made safe, like the proposer can't go back on their word. So as a builder, I feel confident now to release my block. And so the second slot, or the second partial slot, the builder releases the execution payload. So you have this game of commit, reveal, that is there. There's another proposal that the builder would encrypt the contents of their block to a public key that is used for threshold decryption. And the set of attesters is the committee that tries to decrypt the payload of the builder. So if you have, let's say, 2/3 of the attesters that are online, then you can decrypt the builder block. I think it's a nice solution because it avoids like that one-step, two-step thing. But it does mean that you need much more liveness requirement in your system. Like you need to have sufficiently enough attesters online in the network. And in reality, it's the case. When you see the statistics, 99.6% of the attesters are online at any time. But in many ways, the PoS protocol was designed so that you stay live even you are below that critical 2/3 threshold. And so I don't know that we would be ready to make that threshold higher with this proposal.
Interesting. So one last follow-up on this. Is there any progress on the designs that were proposed for friendly fee market? I mean, if we have discussed it, maybe you can mention the name.
Yeah, I would say there's been like some thought on, actually maybe less thought on the in-protocol PBS designs. Mostly I feel because the 2-slot design seemed like it could be specified fairly well. What probably prevents people from specifying is understanding, do we need it at all? How do we do it? Like, how do we do that auction? So there's been work on the mechanism design, but most of that work has gone to trying to make mev-boost more robust. So there are different ways that you can use, and maybe even like some of these ideas I discussed, like threshold decryption. So there's been ideas on how you could potentially remove relays by having builders encrypt their blocks to some kind of committee, or using things like eigenlayer to secure the builder proposer relationship without relying again on these relays. So yeah, there's been kind of like a creative explosion of ways to make these mev-boost market more resilient.
Very interesting. So for people who may have missed the concept of MEV in the first place, we have recorded an episode with Thomas Tanzak on MEV and flash bonds. So it is highly recommended to give a watch about MEV, and then probably learning about MEV boost concept would be a bit easier, only for people who are relatively new.
Yeah, Thomas is a great speaker too.
That's right. All right. My next question is about the roadmap and the timeline. Though you have already mentioned that it is on Ethereum mainnet in a way with the help of mev-boost. Yet I'm curious to hear if there are any chances of having an EIP for PBS in future. You did mention about like the positive and the negative side of having it on the protocol.
Yeah, I would say my feeling is there's still like some research questions that don't seem intractable, but they just like require a bit more thought to process them. So like this idea of block versus slot auction, or what's the correct auction format. We actually had a conference 2 weeks ago in Columbia University where we sort of presented like a lot of content related to this, and had like a bit of a chat with people who think deeply about mechanism design and to try and get a sense of, how can we attack these questions. So it does feel like we're making progress in terms of closing out these open questions that we have around PBS. I wouldn't be surprised that if at some point there is an EIP that tries to specify a bit better, okay, what would it look like if we had this thing in the protocol, and then on the basis of this EIP, people would probably discuss and say, okay, can we do it better? Can we do it another way, or should we do it at all? It's very difficult for me to give a timeline because I feel that I'm much more upstream of the EIP process. But it would be nice if by the end of 2023, like we had a much clearer picture on how to do PBS and if we're happy with the current situation.
Right, assuming that it can be on the like developers and researchers may think of having it on Ethereum protocol. What do you think from your point of view would be the biggest blocker to have it integrated with Ethereum protocol?
Right, that's a good question too. I would say there's really like some momentum behind having it. Like it's on the roadmap of Vitalik, for instance. And for good reason. I mean, it does make a lot of things simpler, like in terms of organizing that relationship. I would say probably the biggest obstacle is convincing ourselves that we're doing that for a good reason and that we are enshrining something that fundamentally benefits the Ethereum protocol and durably. So something that's helpful in the future as well. Yeah, so once that's cleared, I think that would give us like a lot of confidence in doing that at protocol level.
Right. With this conversation, I can say we definitely cannot see it in Shanghai. Obviously, Shanghai proposals considerations are closed. Probably we can target it for Cancun, considering that developers are convinced by that time. Maybe if some kind of research work or feedback from community may be needed for having that things affirmed that it is needed with community support, probably we can see that in future.
Yeah, I do think actually the community support and just generally like community agreement with the idea is very important, because I feel it's a very big change to how we think of the Ethereum protocol. So yeah, there definitely needs to be quite a lot of buy-in to go through that change.
Very interesting. All right, it's time to wrap up. Is there anything that you would like to add or share with the Ethereum community?
Feel free to contribute. I'm always like very happy to talk to anyone who's thinking about these problems. Maybe in the links that I will share, you can find we have some open questions related not only to PBS, but also to things that are maybe more tangentially related. So yeah, if you find that interesting, if you have answers to these questions, or if you have a willingness to think about them, let me hear from you. And if I'm not the person to talk to you, I'm also just happy to connect you to people who might be.
Barnabé, thanks for joining us today to talk about PBS mev-boost and its future plan. I suppose that's helpful for new and existing validators to understand the concept and follow why Ethereum POS chose mev-boost. I hope aspiring devs will continue following Ethereum research work with robust incentive group. And on this note, thanks to everyone watching or listening to this non-EIP special episode. Should you have any questions, let us know in the form available in description, or leave a comment, or reach us at ETHCathar's Discord. Check out description for link to useful resources and guest Twitter to follow. We'll be back with another interesting Ethereum topic, so stay tuned and keep sharing your love with Ethereum Cathars. Cheers.